AS Chemistry, Paper 1, Specimen 0.5. Use the periodic table to deduce the electron configuration of calcium. Well, calcium's got an atomic number or a proton number of 20, so it's got 20 electrons. So it'll go 1s2, 2s2, 2p6, 3s2, 3p6, and then have 4s2 electrons in its 4s2 in its fourth shell. So it's got 2 electrons in its outer shell in group 2. Write an ionic equation with state symbols to show the reaction of calcium with an excess of water. Well, calcium will react with water to make calcium hydroxide and hydrogen gas, because calcium is a metal. So a metal reacts to make the metal hydroxide and hydrogen gas. But if it's an ionic equation, you'll want to draw or write down calcium as Ca2+, because calcium's in group 2 of the periodic table, so loses 2 electrons, and hydroxide are OH- ions. So you've got calcium plus H2O goes to Ca2+, which is calcium ion, OH- ions, which are the hydroxide and the hydrogen gas. You're going to need you're going to have 2 OHs to make 2 O's, 2 O's, 4 H's, 2 add 2 is 4, and the 2 plus and the 2 minuses cancel each other out and make no charge on the right hand side, no charge on the left hand side. State symbols then: calcium's a solid, water's a liquid, these ions dissolve so they're aqueous, and hydrogen's a gas. State the role of water in the reaction with calcium. It's an oxidizing agent because it's turned calcium from oxidation state 0, an element on its own is oxidation state 0 with no charge, to 2+, so it's gone up, it's gone from 0 up to +2, the oxidation state has increased, it's been oxidized. And the water's done the oxidizing, so that's the oxidizing agent causing the other reagent to be oxidized. Writing the equation show the process that occurs when the first ionization energy of calcium is measured. So you've got calcium, it's got to be a gas, loses an electron to form a 1+ ion. So calcium gas loses an electron, there's the electron that's lost, and it's still as a gas, and it forms 1+ ion because it's lost 1 electron. State and explain the trend in the first ionization energy of the elements in group 2 from magnesium to barium. Well, they get smaller. The reason they get smaller is because the ions are getting bigger. They're getting larger and larger and larger as you go down the group, or you could say they're getting more shells. And what's happening is as they're getting bigger and bigger and bigger, then the nucleus is further away from the outer electron, so the electron is lost more easily. The nuclear attraction is less because the nucleus is further away. It's also because there's more shielding as well, because it's got more shells, electron shells, so they will shield the attraction from the nucleus to the outer electrons. So you could summarize all that by saying there's a weaker attraction of the ion to the electron that's being lost.